Hello guys, welcome back to another video with AC loads. We said we talked about a resistive load previously in the previous video. So today's lecture we'll be talking about inductive load, which is AC or alternating current load. We will discuss what is it, where is it used, and what kind of formula we use to calculate the inductive loads. Inductive load is a load that contains coils or winding that create magnetic field, causing energy storage in the form of magnetism. So I will write this down again. I'll say inductive load is a load that contains coils or winding that create magnetic field which causes energy storage in the form of magnetism. In resistive load, what we said, like the voltage and current were in phase, and the power is completely in resistive load consumed as a heat or light. As we said, like the our light and heat system was a resistive load because it absorbed the heat and it just consuming heat. In inductive loads, the current is lagging behind the voltage by phase angle theta, and another behavior is causing lagging in power factor, and energy stored and released is not entirely consumed as it was in a resistive load. Okay, so this is a repetition. Inductive load has a characteristics of three types. Current lags voltage by a phase angle theta, causing a lagging power factor, and finally energy stored and released not entirely consumed as we had it in resistive loads. The examples of these: induction motor, induction motors, solenoid, ceiling fans, and you can name it more. So these are the few examples of inductive loads: induction motors, solenoids, and if you work in a power plant, you will know, and ceiling fans, or any solenoid that you probably heard of using in cars, starter solenoid. Induction motors are like for example, 3-phase or 480 volts AC motor. So these are the examples of inductive loads. I'll have a picture of each example and go a little bit over it, just a brief introduction. So this seems to be a good example of an induction motor. This has the whole body of the motor. Then we have a junction box for the motor to be wired, and we have a keyway for the shaft shaft of the motor, and then we have a motor shaft that which turns the motor any load, and we also have a fan for the motors. So this is kind of quick review for the induction motor. This is a good example of solenoid. It's some sort of magnet. We have a south and north pole, and we have a coil in the solenoid. This is a graphic for you to see like how the solenoid works and how the AC power works. If you look at it, it's alternating, going back and forth, positive and negative direction. So formulas for inductive load is, so here are the formula for the inductive load. We will discuss it in a few minutes. Previous lecture, which is a resistive load, we had a Ohm's law. Well, let's write it down as a V equal to I times R. That was our Ohm's law here. For power, we had I times V. Or you can just derive these things a different way, which will be I squared times R, and also V squared over R. So this was our power and resistive loads. In power factor, or PF, was equal to cosine of theta, which is equal to 1. So that means they're in phase they're in phase with each other. Current and voltage are in phase with each other. So current in phase with voltage. So that was resistive load. Now going to inductive loads. Before going to inductive load, there are a couple letters that we will discuss. We have XL, which is inductance, reactance. We have Z, which we call impedance. We have a J letters, imaginary number part. We have a angle theta, which is a phase angle, and our inductive load section. We have quite a different formulas for that. We had a reactance, which will be inductive reactance. Reactance, that will be, we call it XL. L is for inductance. We have 2 pi FL. Now we also have an impedance. We call that Z, that equal to J, which is a imaginary part. XL of XL, we just say inductive reactance. Moving on to apparent power, we have couple different type of power. Apparent power, we call that S. That is look like 5. S is equal to V time I. So that will be same as true power in the resistive loads. Yes, S is equal to I time V. Now we have another kind of power, which is a real power. And we said that as a P. So P is equal to V time I time, since we have it's a lag, an inductive current is lagging behind voltage, so we have an angle, a phase angle, because sine of angle theta. So it depends how much we are lagging between current and voltage. And now we have reactance power, reactive power. We call that Q. Okay, Q will be equal to V times I, voltage time current, and that time sine of theta. Okay, so that's all these formulas for that. And now coming to power factor. Power factor, which is PF, equal to cosine of theta. We already talked about impedance, which was Z equal to J time XL. And now if you find the actual value of using resistance, that will be a real part instead of that imaginary part. We can use this formula. Z is equal to square root of R squared plus X time L, which is inductor squared. That will find you impedance of calculating the real number with the inductance. We already talked about phase angle theta. How we find it, we will use a tangent. Tangent of theta will be equal to inductance reactance over the resistance, and that will give us a real value of that. Now finally we have a power factor. So if you want to find power factor using the real value, we will use this formula, power factor, which will be equal to cosine of theta is equal to R, which is resistance, over impedance. So this formula will be a little bit addition to what we just discussed. Next video we'll be talking about a capacitive load. Capacitive load. If you want to learn, please go back and check our previous videos, so you have a couple of good understanding of how these thing works. I would recommend go to check that video on a resistive load first to see where we're using those kind of loads, and then today's video, I hope that was helpful, which was an inductive load. And next video will be a resistive load. I'm sorry, a capacitive load. We will discuss that, and we will wrap up this chapter of loads, and we will continue on motors next. Until that time, take care guys, and I will see you in the next video.